Okay, good afternoon. Hello, good afternoon. Hello, can you all hear me?
Yes, sir.
I couldn't hear you all. Can you all hear me? Yes?
Yes, sir.
Okay. Shall we start then? We had some technical problem. We can start. Right. Anyone couldn't hear properly or see the pictures? Can you all see the PowerPoint slides? Can you all see the PowerPoint slides? Yes?
Yes, sir.
Yeah. Kamsat Vadani, are you around? Kamsat Vani, are you around? Because all the time I'll have to catch you because the other batch rep is missing today as well. Kamsat Vani, are you around? She's also absent today. Right. Okay. Fine. Because I want to make sure that everything works before the lectures. Otherwise, we can rectify certain things, right? So that is why I ask whether you all can hear as well as see properly, right? Assuming that all can see, right? Can you all see? Yes. Hope everybody can see. Right. Now, today we are going to start continue with the descriptive statistics. Can you all remember? We started with the topic called as descriptive statistics, and last week we talked about little on sampling. What do you mean by sampling? What type of sampling did you all discuss? Actually, we discussed about three type of sampling. Can you all remember what type of sampling were there? What do you call? First one is
Simple random.
exactly. So I will write it as simple random sampling, SRS, simple random sampling. Can you all see this color, or should I change the color? I will use the black one.
Can see.
I will use the black one. Fine. So simple random sampling. What is the principle of simple random sampling? All the objects are equal chance to be selected. So that is the concept of simple random sampling. All have equal chance, right, to be selected. So that is the concept. All have equal chance. We have already discussed that. Then we don't go for simple random sampling all the cases. We call as stratified random sampling. What do you mean by stratified random sampling? What do you mean by stratified random sampling? So this simple random sampling cannot be applied to a condition called as heterogeneous condition. What do you mean by heterogeneous? If you have different layers, for example, last time we took with the sex, male and female, then we cannot simply apply the simple random sampling. then we supposed to do a system called as stratified random sampling. So we divide the group based on the known factor. That is the concept of stratified sampling. For example, male and female, we have done that. So divide the group into possible categories. These are categories, right? Or sometimes it is called as strata. Categories or strata. So we divide into strata, then we do the sampling, simple random sampling from those strata. So that is the concept of stratified random sampling. We have already seen that, right? I want to make sure all are present, right? Midusha, are you around? Balakrishnan, Midusha?
Yes, sir.
So were you there in the last class?
Yes, sir.
Yeah. So did you did you understand the concept of stratified random sample? Yes, Midusha.
Yes, sir. Yes, sir.
So in which occasion we apply this stratified random sample? When there are heterogeneity in the population. When there is a heterogeneity, right? So when there is a heterogeneity, we go for stratified random sample. No more the random sample, simple random sample will not be valid because the population is heterogeneous, right? Right, Midusha, what is the other type of sampling that we have learned?
Systematic sampling.
Yeah, exactly. Systematic random sampling. So we talked about systematic random sampling. Systematic random sampling is a very easy one. In a orderly arranged situation, we can apply this systematic sampling. So suppose if I want to select 3 objects from this, how many objects are there? In this, how many objects are there? 3 objects. Sorry, 12 objects are there. So n is 12. If I want to find out only 3, so every 4th member become as sample. For example, if this is first sample, second, third, fourth. First, second, third, fourth. First, second, third, fourth. Right? So likewise, you can talk about systematic sampling. So there's a small mistake here. If you have divide by 3, you will get 12, fourth, every 4th member. So we'll have to skip this. This is not the case, right? Just a second. Huh? Who will be the next? The next sample will be? Can somebody tell me? One, two, three, 4. So this will be the next, right? So this is again wrong. So 1, 2, 3, 4. So that person, right? So this is correct now. Every 4th member will be selected as a sample, isn't it? So the next one is 1, 2, 3, 4. So you see, It's a very sequential. So it is systematic random sample. Right? Nilusha, are you around? Veerasuriya Nilusha.
Yes, sir.
Yeah?
Yes, sir.
Okay, so did you understand this systematic random sample?
Yes, sir.
Okay, right, fine. I assume the rest of the class also understood. Right, today we are going to talk about measure of central tendency. So, for example, if you have a data, I can put data into a range, isn't it? Basically, what are, let's say I have 4, 5, 8, 7, 3, 10. So this is my data. How many data points are there? How many data points are there? How many data points are there? This is 1 point.
6.
6 data points are there. So I can order them. For example, what is the starting data?
3,
In ascending order. 3,
4,
4,
5, 7, 8, 10.
yeah, 5, 7, 8, and 10. I have ordered now. So this is a set of data that I have. Now I want to find out this data, because if you have such a big data, very difficult to elaborate about that whole data. So we want to elaborate this data by one figure. One figure. I want to elaborate the data by one figure. So I can use the central tendency to figure out the whole set of data using one figure. So that is the concept of this measure of central tendency. Right? Right. Now, what is the central tendency? Let's look at what are the central tendency available. This central tendency, as I pointed out, is the value that represents a typical or central entry of a data set. Can you guess, in the early example, give an idea which one we can express the whole data set using a single observation or single estimate? Can you guess? Central mean, what do you mean by? Central province, what do you mean by central province? Nilusha, what is central province?
Middle point.
Middle point, yes. So in the range of data, actually, in the range of data, we try to get the middle point. Can you tell me one example how we can find the middle point of this data? There are several ways, right? Okay, so today we are going to see that how we can measure the middle point of a given data. So that the middle point may be differ in terms of value for different data set, but it will refer the same thing. The most common central tendency in statistics are 3. Those are mean, median, and mode. Right? Mean, median, and mode. So mean, have you heard about in your own language what is mean, median, and mode? For a given data, I have 3, 4, 5. What was the data? 7. What was the data earlier?
8, 10.
8, 10. Fine. So these are individual data. Right. Now this is a set of data. I took a simple data set. If you have thousands of data, difficult to write down even, right? So for a given data set, that is what we said here. Data set. For a given data set, this is a data set. This is a data set, isn't it? For a given data set, we can find out these three, which is called as central tendency. So today, at the beginning, we are going to talk about these three concepts of central tendency. Is it clear? Mean, median, and mode. There are three central tendency: mean, median, and mode. Let's look at how we can get those value, as well as how we can interpret those values. Both are important equally, right? Right. First one is mean. First one is mean, right? So mean is important, as you all know. When you come to further on statistics, you will know mean is the most important statistical component in analysis. One of the most important. Mean, in other term, we can call it as average. Mean is called as average. Maybe in this is the simple term. Mean is a more statistical term. Mean is a more statistical term. So usually people used to call as average. Mean is a more statistical term, right? So hereafter you will talk about mean, because you are learning statistics, right? So you will learn about mean. So what do you mean by mean? First of all, there are a few different types of means available. First one is arithmetic mean. The place where we are using this mean also differs, depend on what type of mean that we want to find out, right? So the first category is called as arithmetic mean. What do you mean by arithmetic mean? It is the sum of all the data entries divided by the number of entries. Divided by number of entries. It is the sum of all data divided by number of entries. In simple term, first time we are introducing the term, write down the name of the term. This is right. This notation, sigma notation. This is called as summation notation. Summation. Summation. Summation means adding together, right? For example, this is how we write it. Summation of x, summation of y. So this is a variable. X is a variable, y is a variable. Last week we look at it. Height is a variable which has been defined as x, for example. Yield, paddy yield is a variable which is denoted by y. Okay, so the summation of y or summation of x, which is called as, which is given as using the summation notation. It is actually the addition of all the data entries in x in the data set, right? So that is how the summation notation takes place, right? The mean, when you talk about mean, we discuss about two things. One is population. What do you mean by population? We learned about population. What do you mean by population? Definitely, I will ask, point out questions from all of you, right? Mahajini, are you around? Ravindra?
Yes, sir.
Yeah. What do you mean by population? What do you mean by population? Yes.
The set of data.
The students, those who have problem in answering in English, you can answer in your own language. I don't mind, right? If you tell the reality, that it would be fine. So you can tell me in your own language. Try in English, but if you cannot express it, okay, fine. You can express it in either Tamil or Sinhala, no problem at all. But I will try to explain most of the time in English. If I know some words in Sinhala as well as in Tamil, I will discuss with you. Right, okay, Maheshini, yes? Not Maheshini, I was, yeah, Mahajini. Mahajini. Yes,
The set of the data.
set of data, yes, but this that is fine. Population, how do you call? Because last time we talked about this is population. How do you call this smaller portion of population? This is population, right? How do you call this is Mahajini? This is population. This is sample.
Sample.
Huh? Sample. So sample is a fraction of population. Population mean, I asked, what do you mean by population? Population mean it is the interested item of all in a particular study. All the interested item in a particular study is called as population. So population mean is calculated as, so this is more important. We will be using this term again and again. This is called as mu. Mu, right? This is called as mu, right? So this population mean symbolically indicated as mu. Mu is equal summation x divided by n. What do you mean by n? These are all the interested item in that particular population. So last week we took capital N as an example, 400. Can you remember? Yes, Mahajini, were you there last week?
Yes, sir.
Yeah, so we took an example as capital N 400. So that is actually the population. So this is population. Then how do you call this one? Simple N. We said simple N is 25. That is sample. That is sample size. This is the population size. This is the sample size. So here, the total value or the additions of all the values will be divided by the total number of observations that you are adding here, which is equal to the size of the population. Okay. So mu is equal summation of x divided by capital N. Don't forget that. This will give the mean of. Okay. Right. Now
Yes, sir.
I want to erase this and move to the an example. Yeah. Before that, the sample mean. So that is the difference between population mean and sample mean. You see here, population mean is indicated as mu. Hereafter, if you see this term mu, you should be able to say it is population mean. How do you denote sample mean? By x bar. Sample mean is denoted as x bar. What is x bar? It is the summation of x divided by total number of sample size. So in earlier case, for example, the capital N value is 400. So that is the denominator for this case. Then we said simple n, which is 25. That is the denominator for the second case, isn't it? So this is called as sample size. So the total summation of what you have in the sample divided by the sample size, which is small n. So we have two types of mean. One is called as population mean. The other one is called as sample. Right? Yadurshi, are you around?
Yes, sir.
Yadurshi, are you around?
Yes, sir.
Yeah, okay, Yadurshi, yes. Did you understand the calculation of these two different population means? Population mean and the sample mean.
Yes,
So
sir.
what is the main difference between these two?
We are in the population mean, we are dividing the all set of data entries by the population number.
Yeah.
And in the sample mean, we are dividing by the sample number.
Yeah, sample size. Yes, sample number or sample size. Fine, good. Right. So this is how usually we do calculate the population mean and the sample mean. Later on, we will see this population mean is actually an imaginary mean where we won't be able to calculate the population mean. Later with time, we will see that, right? It's too early for us to discuss about that. But most of the time, we will be calculating the sample. So I think we will take an example to calculate the sample mean. So I have a very simple example. So these are the values: 872, 432, 397, 427, 397, 427, 388, 782, and 397. How many data points are there? How many data points? Each of these are data points.
7.
7 data points. Each of these are called as data points, right? So, right. This is the how we calculate the mean of that. Summation, you simply add all the values. If you add, one more thing about this code, you are allowed to use a scientific calculator for your examination. You don't need to worry about certain calculation. All right. So that you can use the scientific calculator for your examination. Even if we see in the in class, you can bring your calculator. Right. Right. After the summation, you get a value, right? 3,695. This is how do we call this as summation x. Summation x is equal addition of all the values. Right. Now, how to find out our mean value? Mean value is x bar. Why it is x bar, not mu? Why it is x bar, not mu?
Because it is sampled me.
Yeah, it is actually sample set of a data. Only 7 data points. Set of a data which has been taken as a sample, right? So that is why we don't use mu. So we are using x bar. So x bar is equal summation of x divided by n. So in simple term, this value 3,695 divided by 7. So you are getting approximately a value 527.9. So this is the mean, sample mean, or you can write it as x bar. right? Right. Now, the second thing, earlier, what is the mean that we have learned? What type of mean? In
Arithmetic mean.
arithmetic mean, yes. In arithmetic mean, most of the time we will be using arithmetic mean. Time to time, depend on the application, we use other types of mean. So here, the second type of mean is called as geometric mean, right? Geometric mean. This is how geometric mean has been calculated. I would like to ask a question. Do you all have the notes of this with you?
Yes, sir.
Right. Okay, fine. So you can, if I say anything addition to what is there on the slide, you can incorporate into your slides. I mean, your notes, right? So geometric mean, usually we write it as in a general term GM. Geometric mean is equal root of the values multiplied up to any number of values that we are taking as a sample of n, that is the sample size. Simple term. For example, if I say in my example or in my sample, if I say in my sample I have two sample. If it is two sample, I will simply say x1 multiplied by x2, take the square root of that. So this is 2, 1. If I have 3 sample, can somebody tell me? x1 multiplied by x2 multiplied by x3 and root 3. So likewise, this is actually sample size. Is it clear? Yeah, if I ask everybody, no one will answer. I will ask one by one. Yaturshi, you are the one I spoke to you at last. Is it clear?
Yes, sir.
Yeah, fine. It's clear, right? Yaturshi, is it clear?
Yes, sir. Clear.
Okay, right. Fine. So we will move to the further. Let's take an example. These are typical example I used to give in the class, but I will take one more example thereafter. Population of Sri Lanka in 1960 and 1990 was 8 million and 16 million respectively, right? So that means in 1960, what was the population? 1960? What was the population in 1960?
8 million.
8 million, right? In 1990, the population has increased as usual. That is 16 million. Yeah. Okay. Right. Now, the question. Anyone having any problem or chatting? Let me check. Anyone had? Any questions? Right. Okay. Right. So the question that we can ask, suppose what is my Sri Lankan population in 1975? If you do it arithmetically, what you will do? If you do arithmetically, because it is in the middle era between these two. So it is between these two, 1990 and 1960. So what you will do, simply you add 8 plus 16 divided by 2. because it is a progress, right? Population progress. So your answer will be 12 if you do it arithmetically. Whether it is correct, whether it is correct, yes or no?
Nearly correct.
Nearly correct. Who is that nearly correct? I would like to know the answer. You are right, nearly. You are nearly right. Who is that? Good. Nearly right. Right. You see, for example, if you have a relationship like this, or better to use better to use right. If you have a relationship like this, then we can use right. If you have a relationship like this, then we can use the geometric. Sorry, then you can use the arithmetic mean. No problem. Then we can use the arithmetic mean. Right. But if you take the population, this is, let's say, T, this is the population, how this relationship, the relationship, this is called as a linear relationship. This is actually linear. So this is a linear relationship. Do you get a linear relationship or some other relationship for the population growth? For any population growth, not only human beings, even any population. You get a
Increase.
relationship like this. Do you agree? So if I draw it again, the relationship is like this for population growth, right? So this is not linear actually as here. So you see the difference, right? So it is not linear. This is not linear. So in that case, we cannot use the arithmetic. So therefore, we'll have to use the geometric mean. So in this case, how we can calculate the value? Geometric mean is equal 8 into 16 of root 2. 8 into 16 of root 2. So if you take the value, so the answer is, sorry, if you take the value, answer is 11.314 million in 19. That is the population in 1975. Somebody said that nearly correct, but in statistics you can't just say nearly correct. Maybe for grade 5, grade 4, grade 3, yeah, it's fine, nearly fine. But once you come to your undergraduate level, you will have to give the answers precisely. Right, fine, no problem at all. So now you understand the difference between 12 million, which is coming from the calculation of arithmetic mean. Now we calculated using geometric mean, which is 11.314. So there's a huge disparity, isn't it, between these two numbers? So, so this is the actual answer. Do you agree? Right. Now let's say when you measure a tree, for example, I have a tree. This is the diameter. I am measuring the diameter of tree. This is tree number 1. Tree number 2. What has happened is, at the point that I want to measure the diameter, the tree has a branch. So I want to measure the diameter at this point. When you measure the diameter has to be measured at a particular height. You cannot measure the diameter at any point. When you come to 2, you will study about forestry and agroforestry. I will be teaching you how to measure the tree heights and the diameter. So when you measure the diameter, in this case, no problem. Why? Because it has only one branch. Now, if you want to measure the diameter of this tree, just before measure diameter measurement, this tree has branched. How many branches are there? Lakshita, are you around? Don, Chanuka, Chanura, Lakshita, are you around? Lakshita. Lakshita is missing. Lakshita. Lakshita is missing. So Anushka Bandara. Anushka Bandara is also missing. Kamsatvani, are you around? Kamsatvan. She is also missing. It looks like no one is in the class. Jayaratna, Kosgalana Jayaratna. He is also missing. Miss Vijay Sundara, Disanayaka.
Yes, sir.
Madhushani. Yes, Madhushani. Shanika Madhushani. Yes. Can you
Yes,
tell
sir.
me? Yeah, I will ask simple question. Now I want to measure the diameter. So when you measure the diameter, we measure the diameter from a particular height from the ground level, right? Now, if I want to measure the diameter at the second tree, that actually comes at this point, right? Because this is same height as here. Now, what I do, because one tree can have only one diameter measurement, isn't it? So this tree is having here also diameter, here also diameter. So what shall we do? Yes. Yes, Chanika. So here we can apply the geometric mean. So let's say this is D1, this is D2, the measurement. So I will write it here. In this case, only two branches are there, D1 into D2, square root of root 2. So this is the actual measurement of diameter of that particular tree, right? So likewise, in biological field, we can use this geometric mean very often. Right. The third one, which we use very rarely, but in physics we use quite a lot. The third one is called as harmonic mean. Harmonic mean. Right? The people who have already done physics could have come across examples, plenty of examples in harmonic mean. So the harmonic mean is calculated as HM, right, harmonic mean is equal 1 over h, right, is equal 1 over x1 plus 1 over x2 and goes up to 1 over xn. It is the total size of the sample divided by sample size n. Right. Now let's take an example on that. Two vehicles are traveling in opposite directions, right? So two vehicles are traveling in opposite direction, right? One vehicle is traveling in this direction, the other vehicle is traveling on the other direction, right? So one is traveling in this direction, the other one is traveling on that direction. Two vehicles are traveling. One is traveling at 60 kilometer per hour. The other one is traveling at 90 kilometer per hour. Two vehicles traveling at two different direction and two different speed as well. So the question is, what is the average speed between these two vehicles? Average speed between these two vehicles, where we use the harmonic mean. As I said earlier, in agriculture we very rarely use this harmonic mean, but if you come to specialization in agriculture engineering properly, we might use some of this speed calculation, tractor speed calculations and so on, right? In plowing, maybe in sprayer experiments, etc., etc. With the wind speed, all accounting could be expressed in terms of harmonic. Right. So in our calculation, only two components are involved. So that basically we can say it is 1 over h is equal 1 over 60. That is the speed of one vehicle plus 1 over 90. 1 over 60 plus 1 over 90. Okay. Divided by the sample 2. That is equal. You can come up with a simple solution. 5 by 360. So the h will be that is your average harmonic speed. H will be 72 kilometer per hour. 72 kilometer per hour. Right? Clear? 72 kilometer per hour. So that is our answer, the average speed between these two vehicles. Right. Any questions on this mean? Any questions on this mean? Anyone? So all are satisfied, right? Right. The second item is median. That is the second measure of central tendency. Median, the value that lies in the middle of the data when data set is ordered. We can order the data set in either ascending or descending order. What do you mean by ascending order and descending order? Can someone tell me what is ascending and what is descending order? Let's say I have some data, marks of 5 people. Right. Richard Seram, Mr. Richard Seram, are you around? Richard Seram. Miss Indujalini.
Yes, sir.
Can you hear me?
Yes, sir.
Yeah, Indujalini, can you tell me in among these 5 data points, can you put them in ascending order?
Yes, sir.
Yeah, what is first?
20,
Yeah,
38,
yeah,
42,
yeah,
56,
yeah,
82.
and 82, right?
Yes.
So she's right. So this is the ascending one. Ascending order means from lowest to highest. If it is descending order, highest to lowest. So that is called as ascending and descending order. So first we'll have to order them either ascending or descending order. Either way is possible. Then you find out the middle of the data. Let's see. Measure of the center of an ordered data set by dividing into equal parts. So that is the important thing, where when you divide this data, it become two different. For example, now in this case we have put in ascending order, right? We want to split this into two data sets. So who is the middle point splitting data into left side and right side equally? Jalini?
42.
Okay, whoever it is. Yeah, 42 is the middle data, right? So here, in this case, this is the median. This is what called as median. 42 is actually dividing the data into two halves. Exactly two halves. Don't forget. Here we have two data. Here we have two data. So it is dividing the data into two halves. If you have 5 data points, 10 data points, it's easy. If you have 1000 data points, can you do it by manually? If you have A-level marks of students who sat A-level 2019 for physics. For physics, how many people would have sat for physics A-level final, GC A-level? Can you guess? Can you guess the total number of students sat for physics A-level 2019? It's roughly about 75,000 students. 75,000 students. Can I find mean by hand? Manually? Difficult. Can we find median manually? Difficult. Nowadays we have softwares. Very quickly we can find out all these information. Right. Why I am saying this is we are going to talk about Z-score. How many of you have not come to university without Z-score? How many of you have come to university without the Z-score? So everybody will be coming to the university or entering into the university based on the cutoff points of Z-score, isn't it? So we will learn probably next week or week after that. What is this Z-score? So for that, we need all these information. We need this median. Sorry, we don't need median, but we need the measure of central tendency. We will see that. Actually, we need mean. We will see that later. Right. Now, I have a data set. We will apply to that data set. Before that, just a couple of hints. If you have odd numbers of entries, so that means here, is it odd number or even number in our case, this example? 5 data points, they are even number or odd number? Odd number, isn't it? 5 entries. So median is the middle data entry. It is easy. But if it is an even number, Median is the mean of the two middle data entries. For example, I have, let's say I have 6 data points. I have 6 data points. Let's say I have 20, I have 20 in addition to these 5 points. So how many data points I have now? How many data points? 1, 2, 3, 4, 5, 6. Now if I divide the data into two halves, so I am dividing at this point. 3 data on left side, 3 data on right side. What is the problem? The value. We need an actual value to say about the median. So what we will do, we take the average of this, the middle data, that is 56 plus 42, divide by 2. So that, what is the value that? 90, 98. So the value is 49. So that is my median. That is my median. Right? Is it clear? Yeah? Shahika? Mohammed Shahika? Are you around? Mohammed Shahika? Shahika. Mohammed Shahika, are you around? No? Tanupriya, are you around?
Yes, sir.
Okay, Tanupriya, did you understood what is how we can calculate the median when you have odd number and even number?
Yes, sir.
Yes?
Yes, sir.
Okay, right, fine. Now we can use simply a formula to find out the median location. Suppose if you have 5 data points or 10 data points or 15 data points, it's easy for us to find out the median. But if you have, let's say, 100 data points or 1000 data points, how to find out? Right? So this median location, you keep in mind, this is a median location, which is in simple form given as ML, which is equal to n plus 1 divided by 2. That is how we find out the median location. So if you have, let's say, 5 data points, right? If you have 5, let's say, if you have 5 data points, so this is 5 plus 1 divided by 2. So that is equal 3. So that means third data will be our median in 5 data points. Similarly, if I have 6 data points, 6 plus 1 divided by 2, so that is 3.5. So that means my median located between third and the fourth position. All this could be done after doing this data into either ascending or descending order. Without, if you do without ascending or descending order, if you talk about median, so right, then something wrong. If we talk about median without organizing them either in ascending or descending, then you cannot get the actual median. Clear? Kanupriya, clear?
Yes, sir.
Okay, fine. Right. Okay. We'll move to the other slide with an example. Finding the median. So I have the same data set as I pointed out earlier. Now, are these data in ascending or descending order? Tanupriya, is it in ascending or descending order? These are just
Irregular.
no.
Irregular.
These are raw data. First, we'll have to put them either ascending or descending. So we ordered them, right? Jivanti, are you around? Jivanti. Jivanti. Are you around, Jivanti?
Sorry, sir.
Jivanti, can you hear me? Jivanti,
I didn't hear you, sir, clearly.
I couldn't hear Jivanti. Chandima. Chandima Aryaratna. Okay, fine. Yeah, you'll have to speak loud. Right. So, how this data has been ordered? Is it ascending order or descending order? Can you tell me this order? This data has been ordered.
Ascending order.
Ascending order. Right. Good. So you can do either ascending order or descending order. Fine. So after doing the ascending order, what is the number of data that do we have? How many data points are there, Sandima? 1, 2, 3, 4, 5, 6, 7 data. So we can put the formula. For example, we can put the median location formula if we want, so that we can put it as median location is 7 plus 1 divided by 2. So that is equal 4. So that means after putting them in ascending or descending order, the fourth observation will be our median. So this is first, second, third, and this is the fourth observation. This is our median. So here we have 3 data on your right. You have 3 data on your left. So equally distributed. So this is the middle data. Right? Clear? Right. That has been given there. So that is our middle data. The median is 427. I hope all of you understood well, right? Right. Now we will move to the another example. Right. So here, what is the total number of data? What is the total number of data? Sandeepa? What is the total number of data here? 1, 2, 3, 4, 5, 6. Yeah? Sandeepa? 6 data. Now, simply we cannot do it in a way that we did earlier. This is an even number. First, we will have to order the data. Then, we'll have to, there are 6 entries, right? An even number. The median is in between 2 middle numbers. So, in between those two, 397 and 427. So, take the average, which is the median. Right? Take the average, that will be your median. So, median is the value 412, that is coming somewhere there. Right? Right. The last measure of central tendency, which is mode. We looked upon mean, median, and third one is mode. All these are important central tendency. Mode is the data entry that occurs with the greatest frequency. In simple, mode. If no entry is repeated, the data set has no mode. Right? If no entry is repeated, the data set has no mode. For example, let's say here I have marks of 5 people, 32, 45, 45, 60. Can you tell me what is the mode? Vidurshan, are you around? Vidurshan? Vidurshan, are you around? Vidurshan is missing. Tarsiga,
Yes, sir.
all the boys are on vacation. Huh? Including the bachelor. All are on vacation, it's look like. Huh? No one is coming to follow the lectures. Yeah, Tarsika, tell me what is the mode here in our this example.
There is no mode, sir.
Can you guess? Can you just see? Because the data entry that occurs with the greatest frequency. So how many times 20 occurring? How many times 20 occurring?
One time.
One time. How many times 30 or 32 occurring?
One time.
How many times 45 occurring?
Two times.
Two times. How many times 60 occurring?
One time.
One time. Now tell me which is occurring at the most greatest frequency or highest number of frequency.
45.
That is the answer. 45 is the answer. So 45 is the mode in our data set because 45 occurring twice, the rest of the data occurring only once. Darshika, can you tell me once again in this data what is the mode? The data that I am typing. 72, 95. Can you tell me now what is the mode?
There is no repeater, so no mode.
Okay, so all are equally appearing, isn't it? 20 is appearing only once, 35, 48, 72, and 95. All are appearing only once, so that there is no actually mode. So you see, the second, if there is no entry is repeated, the data set has no mode. Clear? Right. We will see some examples. I have one more chat. I will just read. Okay, some have a coverage problem. Okay, fine. Okay, right. If two entries occur with the same number of frequencies, each entry is a mode, right? If right, for example, if two entries occur with the same greatest frequency. So that means not necessary to have equal frequency. It can have unequal frequency, but they are having a very high frequency. Then it is called as bimodal. Right. How many of you have heard about this bimodal in your previous class? Have you heard about Susantika? Susantika Pereira.
Yes, sir.
Have you heard the term called as this bimodal? This bimodal?
Yes, sir.
Where?
Rainfall pattern.
Exactly. Fine, good. So if I draw the rainfall pattern of Sri Lanka for a dry zone, or maybe wet zone. I'm drawing a rainfall pattern of a wet zone. This is for a wet zone. Right. You see how many peaks are there? Susantika, you can answer. How many peaks are there?
2.
2 peaks. That's why we call as 2 modes here, basically. 2 modes. So that's why it's called as bimodal rainfall pattern. Hereafter, if somebody asks, what is the meaning of bimodal rainfall pattern? For example, I mean, even in dry zone, it is true. In dry zone, there's a bimodal like this, because this is for during Yala season. This is during Maha season, right? I mean, you can't say this is Maha and Yala. This is during northeast monsoon. This is southwest monsoon in dry zone. We talk about dry zone. Here in wet zone, these peaks are more or less same. So here also, doesn't matter whether it is a dry zone, whether it's a wet zone, 2 peaks are there. So that is why 2 modes are there. Therefore, it is called as bimodal rainfall pattern. Good. Right. I'll just clear and go. Right. Now, let's look at how to find out the values I have already pointed out. Finding the mode here. Is there the mode here? So for that, very easy, we'll have to either put them ascending or descending. It will help to find out the mode. Yeah. Yes. Susantika, can you tell me what is the mode here?
397.
Yeah, exactly. Because 397 occurring more than once compared to the rest of the data, which is occurring only once. Right? So mode is definitely 397. Simple term. Right? Okay. Finding the example further, a little bit different, because in this case we have a data set, straightforward, so we can find out the mode. Now actually I have taken this from one foreign example, so that's why you have this political party and so on. So nowadays it is very good to see the political party. Unfortunately, I don't have included the political party of Sri Lanka. So this is a political party of one of the foreign country. Don't worry about that. So there are debate of sample of audience members were asked to name the political party to which they belongs. Right, in a group of people, they have identified, categorized the group of people belongs to different political parties. Right. So based on that, what is the mode that we can find out from the response? From the response, the mode. Right. These are the parties, democratic parties, right? Different parties, Democratic Party, Republican Party, other party, and people who have not responded. that also has to be in account, right? So these are the frequencies: 34, 56, 21, 9. Now my question is, find out the mode. How we can find out? Anyone can answer. So here, what is the total number of people? What is the total number of respondents? 6 plus 4 is 10, 11. 11 plus 9 is 20, 0, 2, 120 people. 120 respondents. Am I right? Yes or no?
Yes, sir.
Yeah, 120 responded. Fine. Now, how to find out what is my mode? Mode of response. So I have 1, 2, first person, second person, third person, and goes like to 120th person. So what will be the middle value? If you put them in ascending order, because we cannot put them the parties in ascending order, we can put the number of people into ascending order, right, based on the frequencies. What is the middle value?
60.5.
60.5.
Five.
Are you sure? 60.5 or one less than that? 60.5. Sure? You are right. Correct. 60.5. Why? Because the n is just a second. Yeah, n is 120 plus 1 divided by 2. So that is 60.5. So what do you mean by 60.5? Can we get a person from 60.5? No. So that is actually in between 60th person and 61st person. It is in between 60th and 61st person. So how do we get 60th and 61st person? Where he is falling into? If you start from here, first person, second person, third person, up to 34, starting from here. Then from 35 it goes here. Then from that and so on. So where are this 60th and 61st person coming in? Either he should come either in this category or this category or this category or this category. Where is he coming?
Republican Party.
Yeah.
Republican Party.
Republican. Yes, correct. Why? Because the 60th person, because we start from one person, second person, third person, and so on, it goes. So the first 34 person coming from Democratic, then 35th to the rest, 35th to, what is the value? Yeah, 90, it comes under the Republican. So the middle, the median value, sorry, mode value, right? So I'm talking about median. I didn't come to the mode yet. I'm talking about median. So median value is in between 60th and 61st value, so that this median is actually falling into Republican. So that is median is falling into Republican. That is fine. Now the easiest one. What is the mode? Earlier we talked about median. Median is falling into Republican. Right. What is the mode? The highest number of occurrence. Highest number of occurrence, if you take different political party, here the number of occurrence is 34, here the number of occurrence is 56, here the number of occurrence is 21, here the number of occurrence is 9. So the highest number of occurrence coming under the Republican. So mode is Republican. So here, interestingly, your median and mode, because we don't know exactly what is the median value, right? Median and mode are coming under the same category, which is called as Republican. So that we can conclude, right? So mode is very easy in this example. So we can find out the mode. Actually, this is to find out the mode. So easily you can say Republican are the highest number of frequency. So that mode is Republican. Right, now we are coming to a stage comparing all three aspects of this central tendency. When you compare these three, mean, median and mode, we can argue on which one is better, which one is superior, which one is bad, or which one is inferior, right? You see, all three measures describes a typical entry of data set. All three are giving a description of any sort of data. So all three are good one. However, there are some advantage and disadvantage of using these different central measures. What are the advantages of using mean? Mean is a reliable measure because it takes into account every entry of data. So when you calculate mean, it is considering every data into calculation. So that mean is a good thing in terms of considering all the data. But on the other hand, disadvantage. What is the disadvantage? What is the disadvantage? It is affected by a term called as outlier. What do you mean by outlier? Can somebody tell me what is outlier? What is outlier? What is outlier? Anyone?
Some data little bit contribute in the analysis, but while we consider in mean, it also we took that the data also.
Once again, some data are contribute for the analysis.
Some data less contribute or don't need for the analysis, but even in mean, in calculating mean, we also took the data also.
Yeah, that is fine, because in mean, for example, let's say I have marks of 5 people, right? Marks of 5 people, you see, I have 30, 35, 42, 44, 95. Tell me, marks of 5 students. Can you tell me here, can we find any outliers?
95.
95. Why? You are right.
Is more.
Yes.
That value most far from that other values. Those are below 50, and this is.
Yeah. Actually, yeah. You are right. If you look at this group, you see all these, I mean, if you look at all these values are coming, falling almost closer to each other. We can group them. We can put all these values into one group, where this value is totally deviating from the group value, isn't it? Group value. You see, sometimes this is 3 times bigger than some of the values mentioned here. So we can point out this may be an outlier. Usually that can happen in our data entry also. Now you see I'm entering the data, height data of people, 168 centimeter, 172 centimeter, 174 centimeter. Suddenly, instead of pressing one person is 178 centimeter, 178. Without knowing to you, you have pressed the same 8 key at the last once again. So suddenly, what do you think about this value? What do you think about this value? Sri Divagaran, what do you think about this value?
It is differ far from the other values.
Yeah, you see, normally, is there a person with 1788 centimeter? This is in centimeter.
No,
No, if it is centimeter, what is the height of this person in meter?
17.80.
17.88 meter. I mean, no one in the world with that height, right? So this is actually outlier. What is the problem sometimes? Because this is a mistake by human errors. Human errors are possible. So by mistake, the 8th key, I mean, when you type on the computer, the key has pressed twice. The number 8 key pressed twice, so that there may be a possibility. So suddenly, this has high influence on the mean value. So calculate the mean value and tell me. Add all these values: 168, 172, 174, 1788. Add all these values and divide by 4 and tell me what is the value.
$143.87.
Now, once again, add this value 168 plus 172 plus 174 plus 1788. Add all value and divide by 4.
$143.87.
Once again,
143.87.
I'm saying add 1.
575.5.
Yeah, that is what I want. Why? What is the value?
575.5.
575.5. I will come to that. What I ask is 168, 172 plus 174 plus 1788. This is also centimeter. Add all this value. Divide by 4. How many observations are there? 4. So this is correct. Huh? How do you call this value? X bar. We call this value as X bar. So now you see our X bar value is 575.5. Can you tell me, can you elaborate this 575? On an average, the students are having height of 575.5 centimeter. So that means what is the in meters? how many meters? 5.755 meter, isn't it? Will it possible to have average height of human beings in this value? Siva,
5.75 meters.
yeah? Yes, Arosha? Yes, Arosha.
No, sir.
No, it is not
No, sir.
possible.
Not
It is-
possible. Impossible.
yeah, impossible. 5 meter, even 2 meter is not possible, isn't it? I mean, except certain cases. But average height becoming as 5 meter mean it is a height of a mango tree. Huh? So this is impossible at all. So what has happened here? This is called as outlier. So outlier has a very high influence on mean. That is the problem. So when you enter the data, maybe once or twice you'll have to check the data whether there are outliers. Later we will see there are some techniques available to check the outlier from a data that we will see later on. So outliers are dangerous. So to avoid this outlier, you should cross check the data again and again. Right. So that is the disadvantage of that. Mean is a good one because it is considering all the data points, but unfortunately, it is very sensitive. Write down, it is very sensitive to outlier. Mean is very sensitive to outlier. Mean is very sensitive to outlier, right? Find the mean, median, and mode of the samples. Right? Find the mean, median, and the mode of the sample age, which has been given at the bottom. Right? Tell me what is the mode now.
Twenty.
20, yes. 20 occurring 6 times, 21 occurring 4 times, 22 occurring 3 times, 22 occurring 3 times, 23 occurring 4 times, 24 twice, and 65. Right. What is the outlier here?
65.
65.
Yeah. 65. Yes.
65.
65 is outlier here. You see, all the others are age class. I'm talking about age class, right? Age in a class. It's like a university. Some students are studying at a particular university class in a university. So their ages have been given. Suddenly 65 has come. That is an outlier, right? Which measure? In this case, my question is, we can measure mean, median, and mode. Which is the best for this data? Is the mean is good? Can you find out mean, median, and mode in this example? You have already calculated. I have already calculated. So, which is best in this
Median.
situation? Huh?
Median.
Okay, we will see that. Are there any outliers? I have already discussed that. Let's look at find out mean, median, and mode. So this is the mean. Every student has to calculate in your own. Then only for the examination you can do it better. Don't just read and leave it as it. Maybe I could have done some mistakes in calculation. So to make sure that you are good in calculation, you repeat it and see, cross check whether the answers are correct. Median, this is what median is, 20.5. After putting because already it is in ascending order, so you can say 21.5 is the median. And mode, because 20 years is the one which occurring with highest frequency, so that mode is 20. So which is good, mean or median or mode? Mean is not good. Why? Already we said some outlier is there, right? Because we already said outlier is there. What is the outlier? This is the outlier. So mean is not a good idea to consider it in this data, right? What about mode? Yes. What about mode? Anyone? What about mode? Right. So these are the summary: mean, median, and mode. Because mean is always affected by the data points of outlier. So mean we cannot take into consider. The median also takes every entry into account, and it is not affected by outlier. So that is important. Median, mode and median are not affected by outlier. In this case, mode exists, but it does not appear to represent a typical entry. Why? Why it is not affect? It is not talking about typical entry. The reason is, you see, even though we have a mode, look at all the other values also playing like a mode. 21, 22, 23, because they are occurring more than once. It's like bimodal, three modal, four modal aspects, right? So that is why the mode also not a good criteria for this example. The ideal is median. So this median is not affected right. So if you take this is if you look at the outlier, I'll put it as OL. This is affected with outlier, right? This is not affected with outlier. So even if the outlier is there, median will not be affected. Why? It is the middle. For example, 175, 162, height of 5 people, 159, 159, 1, 2, 3, 177, 178. Now tell me, what is the median? What is the median? Divagaram, Sri Divagaram. What is
175.
175? Good. Now suddenly, as I pointed out earlier, suddenly by mistake I have pressed when I enter the last data. Suddenly I have pressed the key once again of 8. So it says 1788. Now what is the median now?
Now also 175.
Therefore, this median is not sensitive to outlier. Even there's an outlier. Outlier means suddenly you get a unexpected value. So this unexpected value will not, because it is not. Median is not taking this value into account, but it takes as a one value to get the position, so that the position doesn't change, but only the value change, so that median doesn't affected by the outline. The same case by mode, right? Mode is also not affected by outline. Clear? Therefore, in this case, ideal in this typical scenario, I mean, in this age class age of a class that we have seen, among these three measure, central measure, the best is median, because mean is also not a good criteria because it is affected by outlier. The mode is also not good because there are so many modes existing, right? Only mean is sensitive to outline. Any questions? Any questions? Weighted mean. What do you mean by weighted mean? Where did you see weighted mean? Kasuni, where do you see weighted mean? In your case, you have seen weighted mean. Where it is? Can you, in your undergraduate, you have seen weighted mean. Kasuni, are you around?
Yes, sir.
Yeah. Tell me, Kasuni, where did you see this weighted mean? At undergraduate level.
So I can't hear.
You can't hear. Can you now? Kasuni,
Yes, sir.
can't you hear me properly?
No, sir.
Okay, fine. Okay, who is next? Then Kasuni can listen. Nilusha, are you around, Nilusha? Patirange, Madhushani, Nilusha Madhushani, Patirange, are you around? Oh, anyone can answer. Without name, doesn't matter, anyone can answer. Tell me where you are using this weighted mean. You are using weighted mean actually in your undergraduate. Yeah. Bhairavi, are you around, Bhairavi?
Yes, sir.
Have you seen this weighted mean in your undergraduate? Definitely.
Our exam time GPA calculation.
Exactly. That is what I also try to bring from you all. The exam GPA. So GPA calculation is based on this weighted mean, right? So this is a GPA calculation that you all are doing for your first semester, second semester, etc., etc. This is based on weighted mean, right? So this is how it weighted. In your case, maybe you come up with the number of credits is the one that you are using for weighting. Number of credits into your GP, grade point, divided by total number of credits, right? Where W is the weight of the entry. So in your case, that is the credits, number of credits, divided by total number of credits, right? For example, suppose let's say, I'll just have it, just say I have a 3 credit course A. one 2 credit course B plus, right? Another 2 credit course I have A minus. So what is the GP for A? Bhairavi, what is the GP for A? 4.
4.
Right. B plus? 3.7. 3.
7. Oh, 3.3.
I thought I am wrong. Huh? Then this is 3.7. Huh? So now when you calculate it for the first course, I mean for the first one, it is 4 into 4 into 3, because it is 3 credit plus 3.3 into 3.3 into, I have some problem, into 2 plus 3.7 into 2. Whole thing divided by
Number of credit.
yeah. In this example, what is the value?
7.
7. Yeah, fine. Okay. So in this example, it is 7. So this value divided by 7, it's fine. So that is okay, right? So this is how you talk about weighted mean. I will very quickly talk about weighted mean for another example. In case if you have weighted mean, how to calculate for a. This is also exam based. You have all the notes, right? So you can read it completely. You are taking a class in which your grade is determined from 5 courses. For example, let's say 5 sources, 50% from your test mean, that means your test, then 15% from your midterm, 15% from your final exam, and 10 from your computer practicals, and 5% from your homework. Your scores are 86, that is for the first one, first category test mean, then 96 for midterm, 82 for final exam, 98 for computer practical, and 100 for homework. What is the weighted mean of your scores, right? If you take the simply the average of all these, you may get more than 90, but here the question is what is the weighted mean, right? If the minimum average for an A is 90, so that means you'll have to have 90 to get the, right? You'll have to have more than 90 to get an A. To get an A, you'll have to have more than 90 in a weighted average, right? So what is okay. Some have problem, right? What is the, so what is the weighted average? So based on the weighted average, if you don't get it in the weighted average, he or she will be getting more than 90. But here we expected to have a weighted average. So how we can do the calculation for weighted average, right? So in simple, this is how it happens. You see, test mean value is 86. and midterm is 96, and so on, right? So they have weightage. You see, they have weightage. The weightage is totally what? Total weightage is what? So 50%, 50%, right? This other one is 15%, 20%, 10%, and 5%, right? So altogether 100%. The weightage calculation is based on their percentage, that is 50% coming from the test score or the test means, then another 15% coming from the midterm, 20% coming from the final exam, 10% coming from the computer lab, and 5% coming from the homework. So if you add all these weightage value, that is your total score. So now based on this, can we give a grade to this particular student? This particular student is having a marks of 88.6. Particular student is having 88.6. So can we give an A for this particular student?
Can't.
We can't, because already we said if it is if a student get more than or equal 90 marks only, the A grade can be awarded. So here this particular student is not getting 90 marks, so that student cannot get the A grade in simple calculation, right? Right. Right. Any questions? Any questions? I can answer one or two questions if you have such. Yes. Please remember that we are going very slowly, so that we cannot say that 2 hour Zoom lecture will be equal to 2 hour in-class lectures, right? Therefore, 2 hour Zoom lecture can be considered only for 1 hour in-class lectures. I'm going very slowly because of this technical problem and so on. Right. Any questions? What about our batch trip? I think Jeffrey is not around. What about the batchy? I mean, ladies batch trip. Is she also missing today? I couldn't hear her voice. Right. Before I stop, tomorrow morning, what about your availability? Can we do 1 or 2 hour lectures tomorrow morning? Will it possible? Tomorrow morning, will it possible to have 1 or 2 hour lecture? No batch rep, so no one is talking. That is the problem. Yeah. Can we